Now class 10 real numbers. Topic is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic is every composite number is equal to product of prime factors. Every composite number can be expressed as product of prime factors. This is fundamental theorem of arithmetic, and this prime factorization is unique irrespective of the order. The prime factorization is unique. So the definition is every composite number can be expressed as product of prime factors. And this prime factorization is unique. Unique means one and only one. Unique means this prime factorization is unique irrespective of the irrespective of the order in which the prime factors appear. So take any composite number, it can be expressed as product of prime factors undoubtedly. Okay, this is called fundamental theorem of arithmetic. Now let us take a composite number, suppose 56. So how 56 can be expressed as product of prime factors? See, let us see. Prime factorization, let us do. I think you all are aware of prime factorization. So only prime numbers you have to select this side. So now 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14, 7 1s are 7. Therefore 56 is equal 2 into 2 into 2 into 7 into 1. 7, that's it, into 1 not necessary. So this is the way, this is composite number, this LHS is composite number, and the RHS is product of prime factors. Product of prime factors. All numbers, all factors in this product, you can see they are prime numbers, obviously. See how beautiful result is. Composite number is equal to product of prime factors. This is called fundamental theorem of arithmetic. Now our next point of discussion is LCM and HCF. So how to find LCM and HCF using prime factorization method? I'll explain next. Before going to that LCM and HCF, let us do one small problem using this fundamental theorem of arithmetic. See here, one problem I am taking. Show that 3 into 5 into 7 plus 7 is a composite number. So without the actual calculation of the value, we have to say it is composite number. That means using fundamental theorem of arithmetic, you have to state it is composite number. See how I'll do. Now take this given expression 3 into 5 into 7 plus 7. Now take 7 common, so that you will have 3 into 5 plus 1. Do you agree? So this is equal to 7 into 3 into 5 is 15 plus 1. So which is equal to 7 into 15 plus 1, 16. So 16 is 2 power 4 into 7. So it is a product of prime numbers, 2 into 2 into 2 into 2 into 7, 2 power 4 means. So it is product of prime factors. So product of prime factors. This value is product of prime factors. So every product of prime factors is a composite number. So RHS is product of prime factors. So RHS is a composite number. Therefore LHS is also a composite number. Therefore 3 into 5 into 7 plus 7 is clearly a composite number using fundamental theorem of arithmetic. Fundamental theorem of arithmetic. In a short form, I wrote like FTA, fundamental theorem of arithmetic. Chalo. Now, as I said earlier, we'll learn how to find LCM and HCF of two numbers or three numbers or more numbers using prime factorization method. So, finding LCM and HCF two or more numbers using prime factorization method. So coming to the point, first let us take an example. Find LCM and HCF of 120 and 144. Let us take this. Question is, find LCM and HCF of 120 and 144. I will explain this procedure. Please listen carefully. First, prime factorize the given two numbers separately. So first take 120 and prime factorize this. 260s are 120. 230s are 60, 2 15s are 30, 3 5s are 15. So 120 is a product of prime factors 2 into 2 into 2 into 3 into 5, which is equal to 120 is equal to 2 cubed into 3 into 5. So 120 is equal to 2 cube into 3 into 5. Now let us take 144, which is the second number, 144. So now let us take 144. Now let us prime factorize this. So 2 7s are 14, 2 2s are 4, 2 36s are, 2 18s are, 2 9s are, 3 3s are. So prime factorization of 144 is equal 2 into 2 into 2 into 2 into 3 into 3, which is 144 is equal 2 raised to the power 4 into 3 raised to the power 2. So 2 to the power of 4 into 3 square. So like this, given numbers will come what it may be, they are 2 or 3 or more, they are to be factorized, prime factorized, and they are to be expressed as the product of prime numbers. Understood? Next, you take a small table for the sake of convenience. Now let us take a table for the sake of convenience. So you are finding first LCM. So take a table, divide it into 2 blocks. You write the prime factors. Highest exponent. Highest exponent. So prepare a table, divide it into 2 blocks and write prime factors. And highest exponent. Okay. Now what are the prime factors the numbers have? Let us write. You are seeing 2, you are seeing 3, overall prime factors. You are seeing 5. Any more prime factors you are seeing here? You are seeing 2, 3, 5. So you collect all prime factors. And now write what are the highest exponent you are seeing. So for 2 here the exponent is 4, here it is 3, the highest exponent is 4. Because it is 3, here 4, highest exponent is 4. Now for prime factor 3, what is the highest exponent you are seeing? Here it is 1, here it is 2. So what is the highest exponent? Whether it is 1 or 2? 2. So highest exponent is 2. And 5. 5 highest exponent is 1 you are seeing. So like this, please collect prime factors and their highest exponents appear in either of the products. And then what would be the LCM is? LCM is equal, now you raise 2 to the power 4, 3 to the power 2, 5 to the power 1 and multiply. So this is equal to 2 to the power of 4 is 16 into 3 square is 9 into 5 to the power of 1 is 5. 16 9s are 144 into 5. If you take 144 multiplied by 5, 5 4s are 20, 5 4s are 20, 22, 5 1s are 5, 5 plus 2, 7. So LCM is 720. Did you understand? Okay. So now, how to find HCF? So once this side, let us take that numbers which are 120 and 144, and 120 we got as 2 cube into 3 into 5, and 144 we got as 2 to the power of 4 into 3 to the power of 2. Chalo. Now HCF. So previously we have discussed how to find LCM. Now HCF. For HCF also, you please prepare one table, but with different headings. What is the difference? You can see now. So now take table again with 2 blocks. Now here that one block is for common factors, not prime factors. In the previous case, we collect all prime factors. Here we take only common factors. And in the previous case, we have taken the highest exponent of the prime factors appear in the product. Here we take least exponent of the common factor that appear in the product. Least exponent. Now, what are the common factors overall in the prime factorization? You are seeing 2 and 3. 5, it is appearing in 120, but you are not seeing in 144. So, only the common factors are 2 and 3. So, 5 will not come here. 2 and 3. Only common factors you have to collect. Only common factors you have to collect. Now, what is the least exponent of 2 in the prime factorization? You are seeing neither of the prime factorization. Least exponent for 2, it is 3. So, you please take here 3. And for 3, what is the least exponent? You are seeing here it is 1, here it is 2. So, the least exponent is 1. Now, HCF is taken as 2 raised to the power of 3 into 3 raised to the power of 1, which is equal to 2 cube is 8 into 3. 8 into 3 is 24. So, HCF of the given two numbers is 24. Did you understand? Now, we will discuss how to find LCM and HCF of 3 numbers. Of course, procedure is same, but the number of numbers which we are taking is different. The 3 numbers we are taking now as 825, 675, 450. So find the LCM and HCF of the numbers 825, 625, 675 and 450. 825, 675 and 450. So find the LCM and HCF of the numbers 825, 675, 450. Right. So procedure is same, but only thing we are taking 3 numbers. Now first and foremost, these 3 numbers are to be prime factorized. So first 825. Now it won't go with 2. Let us see whether it goes with 3. 5 plus 2, 7. 7 plus 8, 15. So it goes with 3. So 3. 3 2s are 6. so 2, 3 sevens are 21, 3 fives are 15. Next 7 plus 5 12, 12 plus 2 14. 14 will not go by 3, so it won't go. Overall 275 cannot be cancelled with 3. So now next option is 5. So 5 fives are 25, 5 fives are 25. Now again 5 11s are 55. So therefore 825 is the product of prime factors 3 into 5 into 5 into 11. This is called 3 into 5 square into 11. So let us go to rough work, and just because I have to rough everything I am taking. So 825 prime factorization is 3 into 5 square into 11. Now keep it aside. Now I am cleaning the board. Now you go for 675. Now let us see whether it goes with 3. 7 plus 5 12, 12 plus 6 18, 18 goes by 3, and 675 also goes by 3. So 3 2s are 6, again 3 2s are 6, 3 5s are 15. Now here 5 plus 2 7, 7 plus 2 9. So okay, 3 it goes with 3. So 3 7s are 21, 3 5s are 15. Now 5 plus 7 12. So again it goes with 3, 3 25s are 5 plus 2 7, it won't go with 3. So 5 5s are. So 675 is equal 3 into 3 into 3 into 5 into 5. Therefore 675 is equal 3 cubed into 5 square. So 675 is equal 3 cubed into 5 square, and at last 450. 450 prime factorize 450. So now it goes with 2, 2 2s are 4, 2 2s are 4, 2 5s are 10. Right? Now 5 plus 2 7 plus 2 9, so it goes with 3. So 3 7s are 21, 3 5s are 15, 3 25s are 75, and now 5 5s are 25. So therefore 450 is equal 2 into 3 squared into 5 squared. Now alongside I am going to write, you need not write in the exam, because in the examination you will be seeing in your paper, but I am rubbing the board, I cannot see, so that is why I am writing along the side. So 450 is equal 2 into 3 square into 5 square. So 450 over. So all the three numbers are prime factorized, right? Now LCM. Again prepare a table, LCM. From this table you can get LCM. Again 2 blocks, again same headings, prime factors, highest exponent, you collect all prime factors, not necessary to be common. In LCM, not necessary to be common. So you collect all prime factors appear in the products. So whatever you are seeing T, 2 you are seeing, come on pick up. You are seeing 3, come on pick up. You are seeing 5, come on pick up. And you are seeing 11. That's it. So overall you are seeing the prime factors 2, 3, 5 and 11. Now collect their highest exponents in the second block. 2 has the highest exponent here, if you see, it is 1. So 2 has the highest exponent 1. 3 has the highest exponent, it is 3. Here you can easily see 3 has the highest exponent 3. Y has the highest exponent 2. 11 has the highest exponent 1. So therefore, the LCM of those three numbers is 825, 675, 450 is equal to 2 raised to the power 1 into 3 raised to the power 3 into 5 raised to the power 2 into 11 raised to the power 1. So 2 into 3 cube is 27, 5 square is 25 into 11. So if you multiply all these numbers, whatever you get, it would be the LCM. Understood? Okay. So if that calculation you can do now, you can multiply and you can take in your notebooks, nothing to worry, that would be the LCM. Now let us go for HCF. So if you go for HCF, again table, now common factors, not all prime factors, only those prime factors which are in common in all the three prime factorizations you have to pick up. So common factors and least exponent. Now you see what are the common factors you are seeing. You are seeing 3, in every prime factorization 3 is there. In all the 3 prime factorizations you are seeing 3. In all the 3 prime factorizations you are seeing 5. That's it. So only 3 and 5 are you are seeing in every prime factorization. So you pick up 3 and 5 only. And for them, what is the least exponent you have to see? And for 3, the least exponent you are seeing is 1. You see, there is 1, here is 2, here is 3. Among the 1, 2, 3, 1 is least. So the least exponent of 3 is 1 and the least exponent of 5 is 2. Therefore, the HCF of these two numbers would be 3 raised to the power 1 into 5 raised to the power 2, which is equal to 3 into 25, which is 75. So HCF of those three numbers is 75. Understood? So our next point of discussion is relation between the numbers and their LCM and HCF. We are going to connect some suitable relation between the numbers in discussion and their LCM and HCF. So see here, let A and B be two positive integers let A and B be two positive integers and let LCM of AB is equal, we take with this notation, and HCF of AB, the only thing here we are taking with this kind of notation, LCM of AB, HCM of AB. Like this, for sake of clarity, we are taking symbol LCM of AB, HCF of AB. Then now, the relation between the given numbers A and B and their HCF LCM is the product of LCM and HCF is equal to the product of the numbers. So LCM and HCF of the product of LCM of AB and HCF of AB would be equal to the product of the numbers. So you can observe by taking an example also, it is very easy to observe. So now from this, if you take LCM of AB is equal to product of the numbers by HCF of AB, isn't it? Next, another result you can get is HCF of AB is equal product of the numbers by LCM of AB. That's it. So these are the popular results that we can use in solving the problems. Coming to three numbers. So let A, B and C be three positive integers and let LCM of ABC is denoted by in this way, HCF is in this way. Now you see, now HCF of ABC is taken as A into B into C into LCM of ABC divided by LCM of AB into LCM of BC into LCM of AC. So HCF of ABC is equal the product of three numbers into LCM of ABC by LCM of AB into LCM of BC into LCM of AC. This is the connecting relationship between the numbers and their HCF. Now LCM of ABC is equal, again it is A into B into C into HCF of ABC divided by HCF of AB into HCF of BC into HCF of AC. So this is the formula that can be used. So you can treat them as formulae. So finally, these are the relationships between the numbers and their LCM HCF. Okay. Now let us do some problems. Okay. See, here there is one problem. HCF of two numbers is 2 and their product is 120. Find their LCM. This is the question. So solution. Let the given numbers be, let the numbers you consider as A and B. So let the numbers be A comma B. Therefore by given HCF of AB is equal to 2. Product of the AB, which is 120. Now we need to find LCM. So as we have discussed earlier, so LCM is A into B by HCF of AB. Right? So which is equal? A into B is 120 by HCF of AB is given as 2. So it is 60 after cancelling. So the required LCM of the two numbers is 60. This is the answer. Understood? Right. So dear students, the next problem is, if the HCF of 35 and 45 is 5 and LCM of 35 and 45 is equal to 63 into A, then find the value of A. This is the question. So let us take the solution. So HCF of 35 and 45 equal to 5. LCM of 35 and 45 equal to 63 into A. So we know that product of the numbers is equal to the product of their LCM and HCF. So we know that it's a we know this result, or else let us write once. Product of numbers, we know that product of numbers is equal to product of their LCM and HCF. This is a formula. So here the product of numbers, the numbers are 35 and 45, which is equal to 63 into A into 5. So this implies 35 into 45 by 63 into 5 is equal to A. So now this implies, this you can cancel 5 nines are 45. Next 9 ones are 9, 9 sevens are 63. Next 7 5s are 35. So 5 is equal to A, this implies A is equal to 5. So in this present problem, that A value is equal to 5. Understood? So next question is, if the HCF of the three numbers 28, 35, 343, 7, then find the LCM of the three numbers 28, 35 and 343. So we have a formula previously we have discussed. So now I am using that formula directly. So like LCM of 28, 35, 343 is equal to 28 into 35 into 343 into HCF of 28, 35, 343 upon HCF of 28, 35 into HCF of 35, 343 into HCF of 28, 343. So now, which is equal to 28 into 35 into 343 into HCF of 28, 35, 343, it is given as 7 divided by, what is the highest common factor of 28 and 35? 7. 7 into, what is the highest common factor of 35 and 343? It is also 7. The highest common factor of 28 and 340, it is also 7. So you can, by observation, you can tell. If you have any difficulty, you can calculate and tell there is no any wrong. So now what happens? This 7 and 7 gets cancelled, right? So now here you cancel again. 7 5s are 35. Here cancel 7 4s are 28. So what is left over? So 4 into 5, 20 into 343. So 6860 would be their LCM. Understood? Right, thank you.